नहीं कहते सूझे यहाँ से यार तुझसे बात करता है यार फ्रैक्चर मैं कह रहा हूँ मेरे टैब्लेशन में तो प्रेस करा दूँ क्यों करा दूँ प्रेस में क्या लेंगे आप बताइए टेस्ट में Good morning. This is Engineer Suraj Singh speaking from Bharat, India. And this file, this video talk is regarding mathematical formulation, mathematical derivation of formulas on spreadsheet. This sheet that I am showing to you is having many types of formulas. I apprised you before also in past videos how these are derived. This sheet is having formula generation and validation, and I worked on this 15th, 11th, 17th, 11th, 19th, 11th, 25th, 11th, and of course 27th, and I could not pass video to you regarding these geometrical shapes. In this so far I talked about equation ax square plus bx plus c, then ax cube plus bx plus c, then x cube plus bx square plus cx plus d, then equation 4 wl square over 8, then equation 5 wl square 24, then equation 6 complex 5 brackets for complex formula for pi with 5 bracket plus, and equation 8 trigonometrical functions included, then formula 1 a plus b into a minus b, then formula 2 a plus b plus c whole square, then formula a plus minus b whole square, and formula a plus b plus c plus d square is equal to a square plus b square plus c square plus d square plus 2ab plus 2ac plus ad plus bc plus bd plus cd, etc. And then geometrical shapes. This was for validation, but this was only for how to have a trial on such formula. This yellow highlighting you are seeing, this is for open cells, means you can make entries into the cells for whatever variable you have in those formulas. Other which are not highlighted are calculated cells, means you cannot touch them. If you touch them, either you have to keep them protected. If you touch them, you will lose formula, and that's what is not required, not necessary. And you can say that then after that is geometrical formulas, which I am taking as application formulas, for example square, that is, then rectangle, and then it is equilateral triangle, isosceles triangle, right angle triangle, circle, and the sphere, cylinder, then it is cone, parallelogram, after that it is rhombus, and after that it is trapezium another one, polygon, regular, which are now say 5-sided polygon, then it is 6-sided polygon, 7-sided polygon, 8-sided polygon, 9-sided polygon, then it is, you can say, 10-sided polygon, and you can say after that combination of these polygons, like here it is combination of triangle and circle, and after that it is combination of right triangle and square, and it is then combination of triangle and parallelogram, and it is after that it is combined right angle triangle in isosceles triangle plus teeth out right angle triangle, and then combination of polygon of pentagon constructed around square. It's then combination of 5-sided polygon, pentagon constructed around isosceles triangle, and after that so many like that will continue. I like to show you their shapes as well, as I worked on AutoCAD, and to find the shapes like like it is here. You can see here, this is shape. I'll show you now. This is, for example, this one is here, this shape square, and then this rectangle, and then there's an ordinary triangle, that is equilateral triangle, then isosceles triangle, and right angle triangle. Then three sides given of a triangle, circle. Likewise, I have said heads. This is trapezium, and here it is rhombus. Then trapezium other one, pentagon here. It is hexagon here. It is heptagon here. It's octagon here, and this is octagon here. This is nonagon here, and this is you can say what you call it, 10-sided. Yes, 10-sided it is. Decagon here, and after this combination here is a triangle. You can say here triangle ordinary is a combination one. In this triangle and circle have been used. Triangle means triangle and circle, and here it is the right triangle in square, and then it is you can say a trapezium and a triangle within that, and like that it's there. Then you can say an isosceles triangle and some external arrangement with that right triangle. How combine these two? There is a isosceles triangle, then there is a triangle like this which are right angle triangle, and then it is pentagon here and a square and surrounded by pentagon, and this is final shape of that, how it looks, and you calculate formula wise. And after that there is a triangle, isosceles triangle, and there is a pentagon. Isosceles triangle at three corners, pentagon is placed at rotation, and you have to know about that. Then it's ongoing, means not done yet. And this octagon and hexagon. Hexagon has entered into octagon, and this is shape whatever it is. So here what we are doing, I'm trying to give you relation of working. How do we work on this? I last time talked up to, I think I talked up to trapezium as I remember exactly. Square, rectangle, equilateral triangle, and I think we talked up to trapezium, cylinder, cone, parallelogram, rhombus, trapezium. So we will, I think app 14 it is now, we will try to work forward on this, and we see how does it work. That's most important point here. So I don't know what is this. So let's now talk of this and see how does. Now let's take of trapezium. What is trapezium? Trapezium, what is that? This is trapezium. I'm sure I talked about others as well. Did I talk to rhombus? I think I talked about rhombus. Or let me give a fresher of that first. Better I give a fresher, so that those who could not attend at least know what we talked of better. It will take just few minutes, excuse me. And let's say a square. In a square, a side is there and same dimension of square. All four sides are right angle. This is square, and how to calculate that. Side A is there, area square meter, area is 8 open cell, and this A square means whatever dimension it is, it has to be squared, and then we get answer of area. You can see at the same time what I'm writing. There's only number, but when you're writing here, when you're clicking it, this is C66 square, which is cell address, and then you see parameter is sum of four sides, or 4 times A, so this is 4 times this, and diagonal is 2A square under root, 2 into A square under root, and that is diagonal formula, because diagonal is that, very well, base into height, base and height are both equal, so A and A square plus A square, that is 2 square, 2A square, and under root. Then remark in this 3D vertical volume, it's not simply that we consider planar figure, we don't need planar figure also, we are interested in 3D vertical volume also. That's extrusion of that plan figure. You know what is extrusion. When I say plan figure means just 2-dimensional, but when I say extrude, this goes working in 3 dimension. You can say 2-dimensional is planar, and this is 3-dimensional, so 3D vertical volume. So when you say height is there and extrude that, So it shall be 3-dimensional volume cubic meter. So whatever plane figure is there, and you multiply that area or that parameter with depth or height, you get, if you take with square area, it goes into volume, and this is that one, means multiply by height, this volume is square and height, you get volume. And when it's a parameter, some of the area of sides, you multiply it by height or depth of that, you get the vertical surface area, and already you have horizontal surface area at both ends. So you sum up that one, you get total surface area. Same applies to rectangle. Rectangle has 2 dimensions, length and width. Area is length into width, very simple. Perimeter is length plus width multiplied by 2, because both lengths are equal and both widths are equal. All angles are 90 degree in case of rectangle. Then we say diagonal. Now one is A, one is B, so one is A square, other one is B square. If you sum that one, under root, that is under root is here, power 1/2, and we get diagonal of that rectangle, and both diagonals are equal. And then we say 3D vertical. What's that? Again I say, let's give any dimension. So in case of volume, it is planar area, that is here, this is planar area, multiplied with this, you get volume. And again, both ends of rectangular vertical extrusion, both rectangles and vertical surface, which we get here, this is 2 into rectangular end area plus vertical surface area, that is this much. So we get result of solid geometry. Well, I'm not talking of solid geometry or plane geometry, I'm just giving you areas, parameters, and volume and surface area. Volume and 3D surface area. Now we go to triangle, that's ordinary one. What is ordinary triangle? Where nothing is defined, means base and height are defined, we call that ordinary triangle. Base and height are defined just like, here is the base and here is height. This is what is defined. Now say here base is something, height is something, area is formula direct, it is 1/2 into base into height. That's formula. That formula gives us area of that triangle, which is very important factor. Area of triangle, and we get what we want. So here, let us say this is B and this is h height, you can say small h, and half into base into height, this half into base into height here, half C76, D76, this C76, D76, and apex is located, which is not clear from this triangle, it's not given. Let us say apex means top corner. What we when we say apex here, this is apex here, I'm calling this apex. So this from here how much, and this from here how much is not given. So we can assume anything and then we calculate. So let us say that is distance C. So we have B, we have H, we have C. So apex at D, from right end it shall be D. From left hand it is C. So C plus D is equal to B. C plus D equal to B. And this means D is equal to B minus C. That's our calculation formula. Now one is left side, other is right side. So we should know this hypotenuse as well as this hypotenuse to find perimeter, because perimeter is also a requirement here. So to find that, what we do, left hypotenuse, that is based on C, so which we can say h1 c square plus h square. If we want to know hypotenuse of this, we know this one plus vertical is square, and this one horizontal is square equal to this is square, and same way this one is square plus this one is square is equal to this hypotenuse is square. That is general Pythagoras theorem, normal formula which we use. So we say h1 and h2 are known like that, c square plus h square under root and d square plus h square under root. We find hypotenuse both. So perimeter is base plus h1 plus h2 means hypotenuse, which I mean in noting this h1 equal to this hypotenuse. So base plus this hypotenuse plus that hypotenuse, and we are saying that we get that one by hypotenuse. So then we can vertical volumes, 3D vertical volume, height we can take anything. We have volume, that is here, and we multiplied it by that height, so we get volume, 3D volume, and surface area also 2 into end area plus perimeter into h, and same procedure as we applied in last one is applied here with. This is triangle ordinary. Now we go to equilateral triangle. Equilateral triangle means three sides are of same dimension with each angle 60 degrees. This is definition of equilateral triangle, you all know. Side whatever it is, and then we can say area, that is means this is formula, the under root 3 over 4 into C, this is C81, that is you can say area of this comes in this cell. Then perimeter, because there are three sides of equal dimension, so 3 into A, 3 into given dimension, so we get area and perimeter directly. So what is then vertical volume, extruded 3D volume? That is that area which is side here. Height is this one for this calculation, and volume we have to find by using area into height. So we get D81 here. D81 is area, and we have height, that is G81. We get volume, and surface area also we get 2 into end areas, means 2 into equilateral areas, plus perimeter into height, so we get 2 into D81. D81 is area, plus E81, E81 is perimeter, into G81 is height, so we get surface area, and this is your equilateral triangle. So this is a very simple one, but simple or no simple. Formula is formula. You have to drive this formula. You may call by whatever name such calculation standard. You have once fixed such, you cannot change it except variable cells like these are shown in yellow. Highlighted, and you can change the dimensions. I will change each and every dimension one time and show to you how it works. But now I am just trying to explain what I have done for forming these formulas, because these are like macros, open macros. Those macros are given by software, but these macros you have to decide yourself, because they are specific macros, and these do not cover under standard formula of these softwares. So you have to decide your own software, or you can say application. As I'm saying app means application. It's here. So now we go to isosceles triangle. Isosceles triangle, you know very well. This is base is simple. Base is given, height is given, and both sides equal, angle are equal. These two angles are equal. This third angle is 180 minus sum of these two equal angles. So this is base and this is the height are given, and we have to deal with it. How to deal with that? Isosceles triangle, base is given, height is given. Very simple. Height multiplied by base into 1 over 2, as is given here. So we have taken separately. We have taken 0.5 b square here, 0.5 b, and this is h square. So we get hypotenuse. Calculation of hypotenuse is here. Both hypotenuse are equal. So we see b square plus h square under root. So b square is here and h square is here. So this is b square plus h square under root, and we get this formula directly here. Sum f86 and g86 under root. So we get hypotenuse. Perimeter is base plus twice hypotenuse, and that is this much. And then we go to 3D. 3D vertical volume, that is area multiplied by height, and this height is S, and area meter cube per end area into height. End area is E86 here. This is end area into height. This is K86. So we get volume, extruded volume, or solid volume of 3 dimensions. And then we have to find surface area, which is 2 into end area plus perimeter into depth. As usual, so we take it twice E86. Twice E86 is here. That is area double area, and plus I86. That is perimeter base plus 2 hypotenuse, and this is multiplied by K86. Perimeter is multiplied by K86, which is depth or height, and we get this answer. So problem is solved automatically. Now we go to right angle triangle. Right angle triangle. Right angle triangle, I say, in this case, very well, this is right triangle. base into height, angle is 90, and this hypotenuse. These three parameters you have base B, base perpendicular P, and hypotenuse with angle 90 degree. This is given base and perpendicular. Area is half base into height as usual. We do this half base into height. Hypotenuse is the same as base square plus perpendicular square under root. So we get directly here base square plus perpendicular square under root. Perimeter we have base plus perpendicular plus hypotenuse, and then 3D whatever we keep here can keep here, and end is area into depth. This is end area E91 into I91. We get volume, and surface area is a 2 into end area plus perimeter into depth. So 2 into end area E91 is here into I91. We get perimeter and surface areas of this, and also then we move on to triangle with 3 sides. Triangle with parameters, 3 parameters given A, B and C, where there is no angle given, only 3 dimensions are given. We have to deal with this triangle. In this case, side 1 equal to A, side 2 equal to B, side 3 equal to C. I am just giving numbers for reference only. That's not required at all, but just for reference. So S is equal to A plus B plus C over 2, bracket over 2. So these 3 are variables, and this we can chart out from this. Then what I say, S minus 1 is equal to A, S minus B is equal to 2, S minus C equal to 3. Or like whatever comes by calculation, S minus, so its number is itself 3. Now area square meter is S into 1 into 2 into 3, or S into S minus A into S minus B into S minus C. That is area under root of this is square. So this comes as S minus 1 into 2 into 3, like this. It is you can say S is F97. Here is F97, that is S into S minus A, or you can say 1, S minus 2, and S minus A, you can say 1, S minus B, you can say 2, S minus 3, you can say, S minus C, you can say 3, and under root of this, you get area. Perimeter is very simple, A plus B plus C is perimeter, and vertical volume, your height you have to decide how much you take, and volume is end area into H. This volume is end area is here K, this is end area multiplied by height or depth, so we get volume, and surface area 2 into end area plus perimeter, 2 into end area K 97, 2 into K 97, that is area into 2, plus L97, that is perimeter, L97 into height or depth, and so get this answer as well. So these are very simple actually. We will make them complicated now later on. Let's go to first of all circle. Circle, very simple circle is, means there's nothing, radius is given and you have to deal with that. And this is here, radius is given and you have to do with that. That's it. It's very simple, but working is not simple. You can say radius is here. Pi value you can take directly by formula. Pi r square, area of that. So pi into r, you multiply by that, twice r square. Coefficient you have to find, means for purpose of circumference, you have 2 pi r, so you can take out 2, take out pi, and r you have, so you can say it is, you can say 2 pi r here, 2 pi r F103 star or D103 star C103, you get 94 or whatever answer there is, and then 3D vertical height you have, then you end area you have, you multiply that to get volume, and surface area is same as circumference, 2e circumference into h, and 2 into end area, same way 2 into end area plus circumference into height or depth, you get this as surface area vertically plus horizontally. Now we go to next one, and that is sphere. Sphere. This is sphere. Sphere, ball, solid ball. Earth is a sphere, you can say. Your cricket ball is a sphere, football is a sphere, where there is no line, no corner, nothing. Endless sphere is called a circle, a 3-dimensional endless sphere body. So radius is a must there, pi is a must there, and formula of volume is 4/3 pi r cube. So 4/3 is a coefficient there, pi is a coefficient there, and r is variable. So we can say pi is here, you can say coefficient is here, and you can say cubic meter is 4 over 3, that is 4 over 3 is your E109, pi is here, D109, and then R is here, C109 cube. So this is formula. This is 4 over 3 pi R cube, and you get this answer. This is cubic meter of sphere. Now we find about surface area, that is 4 pi r square. 4 pi r square, we have 4 coefficient, pi we have already, r we have already. So we can say here 4 G109, E109, that is here coefficient 4 over 3, that is. So but we know 4 pi r square, so we say 4 pi is there E109, r is there, which is here C109. We get 4 pi r square, and that's surface area. Now about hemisphere, because sphere, and if you cut half in between, equally is a hemisphere. Volume is half of that, so you can say 1 over 2 Fg109 is its volume. This is here volume, and you make half of this, you get volume of sphere. And surface area is a little different, because you just half, you can say surface area is half plus circular area as well. So area, three-dimensional area is half into sphere area plus circle area. So this is half into sphere area plus circle area, that is pi r square. Pi D109 is pi r square. You get all this answer. Now we go to cylinder. Cylinder itself is a pyramid type, or you can say frustum, not frustum exactly. It's it's vertical extrusion of a circle. So it's so easy. We need radius of circle, and you can say height we have because it is cylinder. Pi we have as discussed above, and coefficient we are taking 2 because pi r square 2h. Volume it is pi r square is area of circle and h is height of circle. So you get cylinder. Here you can say pi r square h. So coefficient is 2 here. 2 as in formula, then vertical surface also 2i's here because of 2 circles at ends. So we can say pi r square h in volume, that is pi r square h. Pi is E115, and that is here. Pi r is here C, and C15 square D115, that is h. So we get pi r square h. Volume, then curved surface, vertical 2 pi r h. 2 pi r is circumference, h is height. So we have already 2 there. Pi we have, r h we have. So we can say this formula for 2 pi r h. 2 is G115. Pi is here, this is pi here. R is here, C15 and D. We get this answer. So circle square meter we have pi r square. That was 2 pi r h. Pi r square we have, that is circle square meter. So pi is there and r is there, and you can get this. Total surface area is 2 pi r h, that is this one, plus 2 pi r square. So we get this 2 pi r h, that is vertical surface, plus 2 pi r square, that is end areas of both ends of cylinders. We get square meter of surface area 3D, and we get volume. Then we get a cone. In cone, what is say? Cone, it's a circle area with slanting both sides, and I talked before also. Let me just give another fast explanation of this. Volume of cone is equal to 1 over 3 into pi r square h, and radius is r, height is h, and coefficient we know this is 1 over 3, coefficient pi, and h we have volume is equal to 1 over 3 pi r square h. Volume, so volume there is 1 over 3 pi r square h, and this is this one. We keep F120. F120 is a coefficient 1 over 3 pi is this, and g is the vertical surface, coefficient pi, and this is a pi coefficient 3 over 4. We call it pi 3.14. Then D120, that is radius and square, and E120 is your height. So we get volume, and circle area is pi r square, very simple. Pi we have G120, r D120, and we get pi r square. Curved surface, curved surface pi RH, value 1, because it's in different formula, then it is pi R1, value 2, value 1 plus value 2. This is in formula which we calculated before here. Pi RH, you can use the same values, pi RH and pi R1, and you sum up them, or you can take directly the equation, that is the surface area is pi R bracket length plus height, and this height is slanting height, and this length is equal to m slant inclined height, which is r square plus h square bracket underscore. So we get 20.62 is length of slanting height, and we can say total surface is this, and this is equal to this sum of two. So this is what is called. Now we go to a new one. We go to now to parallelogram. I explained to you last time parallelogram, which is of course I explained in a different way. Parallelogram, we have two sides are parallel in vertical direction. I mean to say at any whatever angle, and two sides are parallel in horizontal direction, but these are not at right angles, these are at varying angles. That's the only difference. So what I have done, it says A, we have base, height we have h. Parallelogram, base and height we have here. Base and height, this is parallelogram, and this is, this angle equal to this angle, and this angle is equal to this angle. This is diagonal, and this diagonals are not equal, but these two sides and these two sides are equal. This height is common for this, and this area is base into height. But we have to see other diagonal, and this will see. We can draw a perpendicular here to find this one, because this triangle based on diagonal 1 and triangle based on diagonal 2 both are equal, and similarly this portion and that portion are equal. So we have to understand geometry first. Then we can say what we are going to speak about parallelogram. We have factors here. A is given, base is given, height is given, angle is. We can say 45 here. We just kept 45, not necessary because it's variable. I say this is 45. We will consider from vertical, rotate this rectangle, and this angle is 45. So I say this angle is 45, this is 90 minus 45. So you can take whatever angle, but for formula purpose I have taken 45. You can change it to whatever you want, even in decimals you can take. So base A into height is area, very simple. And then parameter is twice A and twice hypotenuse. This is parameter, what we say, base into height. But when we say parameter, this plus this plus this plus this, means this base equal to this one. Twice A plus this and this, means this hypotenuse and this hypotenuse. That is what parameter is about. So twice A plus 2 hypotenuse, this parameter, twice this plus 2 hypotenuse. We have to find, that's important. The hypotenuse is here located. We have to find that one. So this is, C131, which is very important. We have to work out for this trigonometrically. Then have perpendicular from left to upward. So what I did, have perpendicular, draw a perpendicular from here onto this diagonal, so that this angle is 90, this angle is half of assumed angle, or whatever angle is there. If you say the 90 minus this is this angle, this is 90 minus this angle, 90 minus this, take an angle. So this is angle, so we can say half of this is that one. So perpendicular is there, hypotenuse is there, and base is there. We can work out this because we can work out this one, so we can work out that. It's not problem. Hypotenuse we can find in trigonometrical formula, and that is there, hypotenuse. We got it through C125 minus C130. C is base minus C130, and C130 is your x. We considered x from here to here. Usually in calculations we consider that, and so we get like that. So we say we got, here we use trigonometrical functions. For example, whatever angle is there, I say sine of this angle, cos of this angle, tangent of this angle, cosec of this angle, sec of this angle, cot this angle. So we got this value of sine 45 here, because this is in calculations, sine 45 here, we can do cos 45, tangent 45, reverse of them, we reverse them, and we got these values of cot, cosec, sec, and cot. And based on this, we got this formula, and we got this square. So no problem, we can got this. So have perpendicular, which I showed to you, is perpendicular. Now angle shall be half of value, perpendicular or hypotenuse equal to Perpendicular over hypotenuse equal to sine half angle. Perpendicular we have equal to triangular height. Perpendicular we have equal to triangular height, and this is, triangular height means we have taken this triangular. So we find diagonal base triangle, this diagonal base triangle, this one, 0.5 into BA, and we got diagonal 1, and we can say this one area of triangle, and then base diagonal equal to this twice height into area. So we got these dimensions. So diagonal we have to find out, that's the important point here. So we got this information now. In this case, what we do, area of triangle is half, area of this triangle I am talking, half of whole area, this is this one, base or diagonal 1 equal to twice into area over height, and we got this answer from here by calculations. This is where formula is involved. And then where we can say, we have both diagonals with us. One diagonal we discovered, we calculated out. We got this diagonal, right? We have got this diagonal. So this diagonal is by simple formula, you can find d1 into d2 over 2. Diagonal 2 equal to area 2 over d1. This we can find d1 over d2 formula. So d1 and d2 area we have, so we can find this one very easily. There's no problem. d1 we have here, area we have here, so this can be worked out. So all are formalized, there is no free cell in this. And then we go to vertical volume. I say area depth of pyramid, and then pyramid, or you may not say pyramid, you may say 3D. I think 3D is better than 3D. We can use 3D term, same should be used same similarly. So I say vertical surface and 3D. Well, I have used pyramid before. It's actually confusing one, so I say 3D calculation, 3D. Okay, let me say 3D. So what it is, area depth of pyramid, so I said that 3D I should say, 3D, confusion should be avoided. 3D, and surface area equal to 2 parallelogram area plus parameter, that's one here, and so it is volume is here, because we have F125 11 I128, so is F125 is here, that is base into height, that's area. So we have this area, depth of this multiplied by depth which is here, so we got this answer. So this is 3D, okay, we'll see later on, 3D it is. So surface area we got here, volume we got here, that's what we had to go. So our problem is solved. Volume, this is surface area, let's say this is volume, I better write, this is area of 3D volume, cubic meter. So we got this right. So we can say, this is what during your making application, you have to check each and everything. That's why trigonometry is very important for you to remember. You have to apply this formula. You have to use sine angle in bracket, sine angle cell in bracket into pi, which is pi bracket over 180. Over 180 is a must because you are not dealing in radians, you are dealing in degrees. So you have to convert pi radians into degrees. So you have to divide by 180. That's very important, or you will get answer in radians, which will confuse everything. Now we go to rhombus. Rhombus is this, this is rhombus. All four sides are equal, because if you push a square, sway a square, you'll get rhombus, but dimensions will change, right? So sides are equivalent, sides are of same dimension, but angle is changed, vertical height is changed. Now rhombus. In rhombus, rhombus here, what rhombus says, the base A, here is base A, we say hey there, angle is given, whatever angle it is, I have taken 15, you can change it. Height is h, that is drawn perpendicular, means A cos vertical angle, and h is height. You can say here, I draw a height here, right? We can take height, means even if it's not given, by for calculation, we can use it by calculations. You just represent that. So I say drawn perpendicular A cos vertical angle. H over B is equal to tangent 90 minus vertical angle. At H over B, H is here, this is H and this is B. So this is angle 90 minus this vertical angle. This is 90 minus vertical angle. I am calling this vertical angle here. So we can say 90, tangent 90 minus vertical angle is this. Now B over H is for H over B is tangent or reverses cot. So we got this cot. B is equal to H into cot value. Now diagonal D1 involved base is equal to A minus B. Now this is diagonal D1 here, this diagonal D1 here. So this I am considering A minus B. This is whole A from here to here to here A. So this is B. I say this A minus B, and this B are also same. So we are taking this way. What we say now, diagonal A, so A minus B diagonal D1 involved base equal to A minus B diagonal D1 square equal to, if we say D1 square equal to A minus B whole square plus H square. So we say this means if this base square is A minus B and this is H and this is B and H. So if I want to D1, what should do? A minus B whole square and H whole square under root, we get value of D1. Right. That's what we see. We get value of D1 here by this formula, A minus B whole square, that is 136, I136 is this, whole square plus H square, and H we have here, that is, H we have E136 and E136 is this, we get this square. Now, diagonal D2 involved base is equal to A plus B. This is A plus B, we are taking this one, if this is diagonal, it's A plus B, this is A and this is plus B, and this is diagonal D2, this is height H, and this is A parallel to that one. Now, see, what we will do is, this diagonal D1, involved 2 is diagonal D2 square equal to A plus B whole square plus H square. So we get this value here. We get diagonal D2 square, so we get diagonal D2 is 7.7, and then parameter is 4 into this dimension. That is 4 into A. We already have A, that is 5 here. So we got automatically parameter there. Very simple. Now what we do? We have to move further and we see given angle is trigonometric resolution is what to resolve? A minus x equal to P chord angle. Right? A minus x is this is A minus x. See, we see, hold on, okay, now we just put the formula for sine cos tan here so that we know with this angle we can find these values, sine angle, cos angle, this angle, and we got hypotenuse 18 as we got in previous case of trapezium. We got it because this is also a kind of trapezium, though it's a rhombus, but formula applies same. So we use before we had different value, which was in that case was here. Now it has gone here. So I not explain all this. You know that, understand that, and there's a notation angle here, but this doesn't matter. Only for formula. Now we see what we have done. Now we have to find his 3D vertical volume and also area by geometry. Now there are two ways to find area by geometry as well as area by diagonals. Area by geometry, if you take angle triangle is half into base into height. Angle triangle means this triangle, this one. This is angle triangle, half into base into height. Base is this much, H is this much, half into base into height. Base means this base B, half into base into height. So we can say half into base into height, which is this one. And means angle triangle, half into base into height is this one. Internal rectangle, that is here. That is internal rectangle, this is internal rectangle, imaginary one here. And then another one here. This is triangle which is equal to same triangle. So we have this in angle triangle, we have this internal rectangle, and we have this, another triangle, angle triangle. So we have three here, one angle triangle, then internal rectangle, then angle triangle. So angle triangle is half into base into height, half into H136. This is H136 here, into base into height E136, E136 which is here, E136, that's here. So we get this answer here, and we get angle triangle geometry, area triangle area. The internal rectangle is A minus B into H, A minus B because we are considering is A minus B total is A minus B is A minus B into H. So we get internal rectangle here, A minus B into H, and this is that I-36. And then angle triangle same as this one, we can just click in and we'll find another way H136, D136. So we get this 3 and sum them, sum into this cell to this cell, this one we get this, and also by diagonals D1 into D2 over 2 is equal to this one, so both are coming same, so validation is done. Now we go to 3D vertical volume, which is area square meter. We have 24.15 here. We take height of this in this cell, multiply this, we get volume, and surface area as we get rhombus both ends plus 4 A into D, so 2 into L139, which is this one area, plus O136 is this one, 4 into A, and we get surface area. So rhombus is solved geometrically as well as this in formula. So rhombus is also formalized. So now we go to trapezium. Trapezium 1 and trapezium 2, one is symmetrical and one is non-symmetrical. Symmetrical, non-symmetrical means, I'll explain, means C and D are variables here. A, B is there, H is there. We put C here and D here so that they can change, they cannot be equal, and or they may be equal, it depends. If they are not equal, they are variables. They are not equal, in that case it is non-symmetrical. If they are equal, they are symmetrical. It depends upon. Means you have to judge yourself. Now what are, A is there, B is there, height is there. A is there, B is there, height is there means, I'll show you. A is there, B is there, height is there. A is bottom one, B is top one. Bottom one is bigger, top one is smaller, or reverse. And height is this. So we can say, similarly it is here, only variation is here. Now what to do? Area we know very well, average of A plus B, average of A plus B, you can say, this cell and this cell multiplied by height, you get area. Now projections we have to understand. Horizontal position over hypotenuse, horizontal position over other one, below C slope, hypotenuse. So what we say? This hypotenuse below C, this hypotenuse this is projection, we have unknown, this is unknown, this is unknown, this is unknown, this is unknown. We have to find this. Sometimes these are given, not unknown, or we can work out if we know. Suppose B, A minus B is something and both are equal, we can say A minus B equal to whatever, divided by 2, you get value of C and E if it is symmetrical. Otherwise you have to find out what is that. So we are talking of symmetrical, so you can say A minus B over 2 you get here, and A minus B you get here, so both are equal. And below C slope, slope we can find because below C and below D, below C what I mean to say is, below C is this hypotenuse, so this is square plus this square under root this is square plus this square under root this, that's formula we can use here, and you can find this. This is that, this is square, this square plus this square under root, and this square plus this square under root, both we find. So below C and below C we found both, because it is symmetrical, so they are equal. Now 3D vertical volume is very easy. Area we have here, that is in a cell 140, F148. We have average of this, so we can say 3D vertical volume is this area we have here, that is F148. So we can say here, yes, F148 into L148 left, and we get this answer. And surface area into 2 plus perimeter, surface area of trapezium into 2, that F148 here, that is surface area. Surface area into 2 plus K148 is here. Perimeter A plus B plus C multiplied by this L148, we get this one. So we have solved one symmetrical trapezium. Now non-symmetrical trapezium, that is where sides, projections or offsets are not equal. That you understand very well. In this case, we say non-symmetrical means bottom is known, top is known, height is known, area is known, but horizontal projection over hypotenuse left C, horizontal projection over hypotenuse right D are not known. They are changing. You can keep whatever you want. They are not equal. They are not in 3 say like 3 and 3. So they are varying. So it depends on you what way you want. Below C slope hypotenuse, that is we have to calculate. Below D, below C and below means we have to calculate below C this and below D this. We have to calculate ourselves because this is varying, and when it is varying means this varies, and this varies. Vertical remains constant. This square plus this square and this square plus this square and this square. As usual, we get and we find. So below C hypotenuse is this square, C square plus H square under root, and similarly this square, D square plus H square under root. We get both parameters A plus B plus C, which is this one. We have this A plus B plus C. So we got this 3D vertical volume. We have, so we got parameter A plus B plus C because A plus B we have, and we got other one A plus B plus C, and A plus B plus, we got this hypotenuse, so we can sum up them for purpose of this. So we can say this is below slope C and D both we have here. This one we have by this calculation, this one we have by this calculation, both hypotenuse. So parameter is A plus B plus C hypotenuse, A plus B plus C hypotenuse plus D hypotenuse. Both hypotenuse are there. So we can say C155 which is here, D155 which is here, means A plus B, plus I155 which is here, 6.4 below C hypotenuse, and below D this is 5.39. So we can sum up them, we can find this parameter, and height, depth we have. So volume is area into depth. So we have area is here, that is, that area is here, F155 multiplied by L155, L is here depth, so we get volume, and surface area is area twice trapezium, area is here, which is F145 to twice plus K155, which is perimeter into L155, we get surface area. We solve non-symmetric trapezium. Now polygon. We have to start a new series of polygon, in this case polygon, regular polygon. Take some water. तो पानी ले गर्म करके इसमें से गर्म करके पानी लेगी इसमें से गर्म करके दे तो दे रही है उसको दे रही है बैठे बैठे जाम हो गया. So polygon I'm talking. सुनो ले मैं बैठा हूँ. Polygon, say polygon. Polygon means whatever figure more than 4 sides is known as polygon. It can be regular or it can be irregular. I am considering regular in beginning because there is no limit for irregular. We just want to understand how we solve them, and it's starting with 5. This is 5, 6, then 7, 8, 8, and then 9 and 10. I'm taking up to 10 currently. After that, we will take combinations of these, means combination of various figures. Now let us start with polygon 5. You know what is this polygon 5? What is this actually? If you maybe let's blow up and see how it is. Let's say, voila. This is A, and this 5A are there. 5 sides equal length. This angle is 108. Include internal angle, or you can say inclusive angle, not exclusive one. Internal angle is 108. This means 108, 108, 108, 108, and 108, 540. 540 is angle of 5. So when we say 108, this is right angle, this is 18 degrees, and you know, this is what I say, I nominated like this. This is here x, 108. So other one is 72, means total is 180. So now this angle is 38, 36 here. This is 18, this is 90, this is 36. If we do like this, 36, and you know, if you say this 36 and this 72, so it is 108. 72 plus 36, 108. Now we have to solve problem. A we have, and we have, let's consider that we take A here, then we say this B, and we say this C, and we say this D. We have to find out this first to know different dimensions of this. To find different, we can take direct formula also, which is here, that is, this is here. We have area form base, formula base, that's this A square multiplied by number of sides divided by cotangent bracket 180 over n. This is direct formula, but we want to do research work, we want to do engineering work. Direct formula doesn't give anything except area, but we have to find various parameters also for purpose of this geometry of pentagon. We have to find A is given, we have to find C, we have to find B, we have to find D, and angles we have, we can find these angles from drawing, it's a regular drawing. So this angle is 108, this angle is 36, this angle is 72, and using these angles and this triangle by using trigonometry, we can find these positions like what is value of C when this is 18 degrees, because this is 108 degrees, this is 72, this is 190 degrees, so balance is 18, so this is 18. So we have 18 angle, we can find B, which is A sine 18, we can find C, which is A cos 18. Similarly, it is 36, we can find D, which is A sine 36, and we can find this also B. We can find, if we wish, we can find this half also, though it's not required currently. We'll see in D, when you find D, at that time we'll find this. So how we'll go, we'll see now. It's chart here, it's complete formula, polygon regular, 5 sides, and angle is internal 108. So we say it's called pentagon. It's that pentagon we call it. We call it pentagon. What do? One side is A. Pentagon, I say B is A sine 18. I can show like this. B is A sine 18, this is B, and angle is 18. A sine 18 is B. Perpendicular or base, or perpendicular or hypotenuse is sine, perpendicular or perpendicular or base is tangent, and base or perpendicular is cos. We are talking base, perpendicular or base, that is sine, and because this angle is opposite to that side, So we take B is equal to A sine 18. We say C is equal to A cos 18. A sine 18 is B, A cos 18 is C. And D here, D is A sine 36. A sine 36. We have three missing points here. We can use like this. We say D 162, which is A sine 18, and pi bracket over 180. So we got value of B. Similarly, we get value of C like this, just placing cos 180, cos here in place of sine, and we get value of D by just placing sine and sine 36. So we got these three, A, B, C, B, C and D. B, C and D we got. What's left now? We have B here, we have A here, we have B here. Now, this is known, and this is known. This is known. D we have D, we have C. So whole this is known. It's so simple. So what way we go now? Area geometry based, it says. Area geometry based. What geometry based area says? Geometry based we see, it says that bottom trapezium, this is this one. This is bottom trapezium, right? And then top triangle. This is top triangle cursor like this. So one is trapezium, one is triangle. So we have all parameters here available, worked out from geometry as well as from calculations we have here. So what we say, bottom trapezium area, this plus this, A plus this multiplied by this, A plus this multiplied over 2 by this. That's what we know, right? This plus this half multiplied by C, we get area of this, right? So how it is, you see, here we say A, this is A plus B plus C, A plus B plus A plus B divided by 2 multiplied by C. I repeat, this is one side A plus another side is B plus A plus B. Sum of these two divided by 2 multiplied by C. It's here. And here is this multiplied by this into half. B plus A plus B. Right? B plus A plus B. You see B plus A. I say here half. B plus A plus B, this is one dimension, multiplied by D, another dimension, and half. So that is another area. So we have two areas here. You can see A plus B plus A plus B half multiplied by C, that is here F162, and we get this answer. A, D162 is A, E162 is B, D162 is A, E162 is B. So we multiplied by 2, C is this 162F, and we got half of this into this. We get area of this one. Similar to this triangle area, we get like this on similar basis. We get B plus A plus B. B is here. This is, B plus A plus B, half into plus A plus B into D. So B here is this 162, E162, and D162, and E162, G162. So we got this answer. We have both answers here, both sums here. We do both sums, so sum of H 162 and I, we get answer here, geometrical answer. And when we use this formula, we get this answer. So both areas are equal. And how we get this A square N? It is A square N. Let us see. D162 is A. This is A square into C159, and C159 is, C159 is number of sides 5. So we say A square into number of sides. A square is that number of sides, that is number of sides here 5, and C159 that is, so A square number of sides divided by 4 tangent, 180 over n divided by, here it is, I have taken a square n here, and these are 4 tangent k160, 4 tangent, and that is tangent is 4 tangent 180 over n, k160, k160, that is here 180 over n. Here there. ज़्यादा नहीं है?
नहीं गिरा मत दी। कैसा मीठा खट्टा?
खट्टा खट्टा मतलब
ज़्यादा मीठा है?
मीठा कहाँ से आ गया इसमें?
गाजर थी ना ज़्यादा।
अच्छा ठीक है,
हैं?
ये मीठा है।
मीठा है कि खट्टा है?
मीठा।
गाजर ना चुकंदर मीठे होते हैं ना, गाजर चुकंदर।
So we got this area here. So we can say that we validated this area by formula to this area by geometry. To me, geometry formula is more important than this formula because this gives direct calculation. But I don't want direct calculation. I want analytical calculations. These are analytical calculations here. Now, further, in that parameter, how to find parameter? It's very easy because A we have and number of sides we have. We can multiply 2 because it's a regular one. This is not irregular. So perimeter is very easy. Perimeter is very easy. Depth we have. We can 3D vertical volume we can find. Depth we have, and that is area into depth. I-163. That's area into depth. We got this one, and surface area same 2 into polygon area plus perimeter into depth. So we have here twice into end area, so I-63, that's this one, plus perimeter into this one. We got 5 minutes. So we solve this polygon. We go to hexagon, that's six-sided regular polygon, and it's called hexagon. Hexagon, Hexagon, 6 sides, polygon, equal sides, means regular polygon. Hexagon. Let's see geometry first. This is geometry of polygon. 6 sides. A, 120 here, 30 this, and 60 this. 120, 30, and 60. Now let's see. Again, A is known, B is unknown, C is unknown. C1, B, and C we find out. Six sides, angle 120, As we said there, angle 120. A, B, C. A is known, B is A sin 30, C is A cos 30. This is A sin 30. A it is 71, 171, sin 30, pi 180. We get sin B value, here B value and C value by cos 30. We got these analytical values. These values are very important one because these will give us our results. Now, I call it area geometry based and that is area formula based. I am using geometrical based because this is more analytical rather than using area formula based. In formula based, I want to understand the correct answer from the area, but I need all parameters because I have to work out quantities, I have to work out so many things, so we need everything. Here, bottom trapezium and top trapezium. Bottom trapezium and top trapezium. This is bottom trapezium and this is top trapezium. In fact, both are equal. We have A and we have this B plus A plus B, B plus A plus B, A plus B plus A plus B over 2 into this distance C. So simple. Let's say bottom trapezium A plus B plus A plus B half into C. Similarly, top trapezium is same, no difference. So we can apply this. You can see D171, that is side, known one, filled one, then E171, that is calculated base, B calculated B, and then D171 and E71 repetition, divide by 2 for average and multiplied by F171, that is cos C value of C. Now we got this, sum of this and sum of this. This is that, this is other one, top trapezium. D171 is same, means varies, and we have to sum up these two, H171, and we get this is total area. And we get by this formula as well, A square n, that is this one, this is A square n, we get, then 4 tangent negative, we got this area, so 259 and this is equal. So this is validated. Now move on to 3D parameter. We have this, so 6C168 is this, and 6 into this, we get parameter. Depth we have here, then volume, that's the point. Volume is area into height. Area into height. I172, this is area into height is here, so we got this. 2 into polygon area per parameter depth, so 2 into polygon area plus parameter C174 here, C174, this parameter into height of 174, and we got this answer. So we solve hexagon. Polygon regular 7 sides. Seven sides now. Seven sides. Blow it up. You see this? A, 7 sides.
This angle is 129 here. This angle is 90 and this is 39. And this is 51. This is 77. This is 26. This is 64. This is 26. This is 13. This is 13 here. 13. See angle? 129, 39, 77, 51, 13, 26. This is 26. This is 13. This is 26. This is 64. Again 129, 13, 51, 77, 13, 26 and 64. We have A, we have B, we have C, we have D, we have E and we have F. Watch carefully. A, B, C, D, E, F. When we have B here, we have A here, and again we have B here. We have D here, we have E here, so this is also E, this is B, this is A, this is B, this is A, and this is B, this is D, this is E, this is E, this is F. So we can combine all this and we can combine all this and we can get answer. Alright, we go back. We go back here to try what to do, how to drive this formula. Now, let's say 7. This is 7. This is angle 129 as you said, side given. B is a sine 39, C is a cos 39, D is a cos 39, E is a cos 26, F is a 2. So you can see here again A, B here, reference to this angle 39, and B is reference to this angle, C is reference also to this angle, C is for cos and B is with sine. A, this is D, which is also with cos, and also here B, which is a sine, and E is with this one with cos, and F is with sine. So this is A, this is B a sine 39, C is a cos 39, D is a cos 13, and E is a cos 26, F is 2a sine 26. Work out. A sine 39, A is D180, yeah, A sine 39, D A cos 39, cos 13, yeah, this is cos 26A and 26. We know all this. Now, area geometry based. This is bottom, this is top trapezium here, this is bottom, this is top, and this is top triangle. There are 3 figures now coming out or revealed out of 7-sided polygon. Let us see how much is this. Now, A plus B plus A plus B. A plus B plus A plus B divided by 2 and multiplied by C. Then B plus A plus B plus E divided by 2 into D, and then half into E plus C into F. That's it. So we have this formula. Now this is A plus B plus A plus B over 2 into C, 2C, and this is same way, B plus A plus B plus E plus E over 2 into G 180, and half into E plus C. We get, E is E 180, half into E plus C into I plus F 180. Got this. So these are triangle areas. Trapezium 1 means this, and trapezium middle one, and this top. Sum of this, this and this, we get this answer. And by this formula we get this answer, which is just calculated 364, and it's also 363. So can say this is a square n, that's a square n, and this is 4 tangent, and 178 4 tangent, that is 180 over n, because this is n. So we get this answer. Now we have to see parameter and solid. Now we get polygons 7 times the C177 into D80 180. We got this parameter. Vertical volume, we have say whatever depth. So volume is equal to polygon area into depth. This is that one, K181 area into depth. We got this. Then surface area twice polygon area into plus perimeter depth into depth. So this is twice K81 here 181 plus depth is this perimeter C 183 into F. So that we got this perimeter. This surface area of this solid geometry. Now we go to polygon 8 sides. So you call it octagon. See that A, it is 135 and this is 45, so no difference. A, B, C, right? This is symmetrical, so B, A, B, C and C, we can assume no need of D. 45 here means 45 is here. This is 90 is here. So we can do it further. Let's go. And see, easiest it is though it's 8, but it is easy like hexagon. Easy like hexagon. So polygon 8, sided octagon. Let's say it's 8 here. This is octagon, so 8 sides. 8 sides, and we have seen angle. That's very clear to us, which is 135. 135. So angle is 135 and dimension is A here. Oh, sorry. So we are saying now 135 here, side is known. You can find B is equal to A sine 45 and A is C is equal to C cos 45. Let's show how. This is B and this angle here 45, so B is A sine 45, C is A cos 45. It's very easy. We can say D189 sine 45 and this is cos 45, value is equal in this. Sine 45 value is equal for both sine and cos 40, angle 45. Now geometry based step bottom trapezium, mid rectangle and top trapezium. This is bottom trapezium, mid rectangle, and this is top trapezium. Let us say A plus B plus A plus B over 2 into C. Here B plus A plus B into A, and top is B plus A plus B plus C, B plus A plus B plus A over 2 into C. This is the formula. Now let us see this. A 189, that's this one, and this is D 189, this one, plus E 189, that is E 189, that is, you can say B, which is here B, and A is here, B is here, plus again that same one, and over 2 into C. C is this F189, if we get this answer. Similarly, B plus A plus B, B plus B is here, which is 189, D189, E189, sorry, this is B. B is E189 plus D, that is A is D81, and again same as D189. So we got this value. This value we got, this you can say two spaces of decimals I can do. We got this value, and B plus A plus B plus A, that is for trapezium. B, that is here, E189, D189, E189, D1 over 2 into C is F1. So we got 120. So we get this sum of this is Hij, is sum of, this is area of this 3 figures, 3, 1 rectangle and 2 trapezium, or 2 trapezium and 1 rectangle. Formula wise, if you see, this is also formula wise 180, this is a square n over 240 this n. This is 22.5 by this formula here. This is 180 over c 186, that is number of sides, which is 8. So we get this one 22.5, and we take this here 4 tangent. This angle, yeah, you got this value, and a square n is this value. So we sum up these two, we got the same answer. So this is equal to that one. Now we see parameter here. This is 8 number of sides. C it is 1 is this that one. D into this, we got answer. Depth, whatever, and volume, polygon area plus depth area we have here. J189, J190 into F192, and we get volume. Surface area is twice polygon area plus perimeter depth. So twice polygon area, that is here, C192 into F192, C192 8 into F192. These dimensions, we get this one. So we solve polygon 8 or polygon 9. Polygon 9, view this. I'll be back in 2 minutes. Right, hold on. You have to go to urine and come back. First, what we do meanwhile, you can watch this figure. It's very important one. So, I was talking of, this is uh, 9-sided. This is polygon. Oh. Nonagon. This is nonagon, and this is here. You can say A, all same according to regularity of polygon. Then we have here one trapezium. We have there another trapezium. We have there another trapezium and a triangle. So we have 3 trapezium and one triangle to resolve. We have to solve them, right? That is where we have to work. This is A. Sorry, gentlemen. So this is A, this is B, this is C, this is D, this is E, this is F, this is G, this is H. Again, A is there, B is to be found, worked out, C is to be worked out, A we have, and this C again is equal to this. This is equal to this. We have D like this, E here, so that we get this same, and F we have to find, G we have to find, H we have to find. This angle is 140, this angle is 50, this angle is 40, because 40 plus 50 is 90, and 90 here, this is 10, and this is of course 10. This means this is here 80, and this 160, which is 80 plus 160, so this is 140. And we have here on top triangle, this is here 30, this is 20 here, and 140 here. We have these A, B, A is known, B, C, D, E, F, G, H are all going to work out. So what we have to work out? We have to work out 1, 2, 3, 4, 5, 6, 7 dimensions. B, C, D, E, F, G, H. B angle is here 50, so B is A cos 50, C is A sin 50, D is A cos 10, E is A sin 10, then F is if you take this angle, in that case it is, depending which angle we take, so F could be A sin A, now it should be angle of this angle. So you see which angle we take, it depends upon that. If you take 30, it becomes cos, A cos. If you take this, it becomes 1. Same way here, and you see how we move. We say this 140, this A, B, C, D, E, F, G, H. You see all are there. We have 9 here. Angle is 140. Side A is known. Side B is A cos 50. Side C is A sin 50. Dimension D. Side we should say A. Actually dimension it should be B is A cos 50. C is A sin 50. D is A cos 10. E is A sin 10. F is A sin 60. G is A cos 20. H is A sin 20. 1, 2, 3, 4, 5, 6, 7, 8, 1 unknown, this is not known, 1, 2, 3, 4, 5, 6, 7 not known. So we can apply now rule. A cos 50, A is known, 198, cos 50, sin 50, cos 10, sin 10, and sin 60, cos 20, sin 20. So we have to move to what we have to say now. We have bottom trapezium, is this one. We have mid trapezium, that is this one. Then we have mid 2 trapezium, then top triangle. We have 4 geometrical figures in this analysis of none other. This is, we have 4. हाँ नहीं खा लूँगा, सब्जी बनानी होगी ना, ठीक. So in this case, we have bottom trapezium, let us say A plus C plus A plus C over 2 into B, right? Same way we say this C plus A plus C plus E plus C E, wait a minute, we say E, let us say again, make 2, this is C plus B, or we can say from here, whatever side we say, it doesn't matter, we say, let us say E plus C, E plus C, C is up to here, E plus C plus A plus C, E plus C here, this one, E plus C plus A is here, plus C again, same dimension, because it is equal to C plus E. So E plus C plus A plus C plus E plus G and G. G and G. We are talking on mid one. I'm talking on this one actually. This I was here. Well, it's here first. Let us discuss. These two are equally symbols are actually confusing. Let's see. One we have already discussed. Let us see. Sorry, C. C. This is here. Plus A. This is here. Plus C. That is here. Plus E. Plus C. Plus A. Plus C. Plus E. That's okay. And that is here. And we have to see that divided by 2, so we have divided by 2, this and this divided by 2. Again I say C plus A plus C plus E plus C plus A plus C plus E. Divided by 2 and then D multiplied by D, we get mid A trapezium, mid 1. Now mid 2 here, this is trapezium again, E plus C, E plus C plus A plus C plus C, E plus C plus A plus C plus C plus G over 2 multiplied by this F. Now on top triangle, this is that one, let's see, half into G plus G into H. We got these three for calculations here. Let us try now what we did. We did here. Let's move to that here. Now CAB we have confirmed. This is A, of course. B is A cos 50. C is A sin 50. D is A cos. A is D90. D 198 here is A. So that is D 198. So A is everywhere. A is somewhere it is A, somewhere it is B. So where it is A, it is D198 cos here. C is also A, so it is there, sin 50. In this also A cos 10, also A sin 10. We are using hypotenuse as a variable so that it supports this hypotenuse of x. So sin 60, this is cos 20, this is sin 20, and with this we say all these 1, 2, 3, 4, D198, 2, 3, 4, over 2 into 198, E198, E198 here is this B. Where is B? And also we can same way say these parameters F198, this is here C, plus A is here D198, plus F198 again C, plus E, like that E is here H, and H is there again F. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 dimensions divided by 2 into D. There is D, and we can say D is here divided by D, G198, G198. And make 2, we go to make 2, we'll find same. Again, 1, 2, 3, 4, 5, 6, 7 parameters. H198, which is E, plus C, that is, F198, plus A, that is D198, plus C,
plus C, that is F198, plus E, that is H198, plus G that is J198, and plus J198 divided by 2 multiplied by I198, that is A cos 20, multiplied by I190, A cos 20, and A cos 20 means that is G, and we get this I198, that is F multiplied by F here, and then we go to top triangle, that is half into G plus G. G here is G G, that is 198, J198 plus, that is J198 into K198, that is K198, that is H, K198 H, and we get these 4 areas. We get 4 areas here, and if you take sum of these 4 areas, sum L198 to here O, we get this area, and by formula we get here it is 20, 180 over 9, and A square H, D180 square to C195, 900, and we will take this value here. We get 1 for divide this, we got 618.18. So according to formula and according to geometrical pattern, we have reached a conclusion that same. Now polygon regular 10-sided. 10-sided you might not have used it, but I'll take it further also later on, 11 or 12. Let us see what is 10-sided actually. It's a little complicated, but it's easy, not difficult. It's 10-sided, 10-sided. 10-dimensioned it is, and it's really interesting to see. Maybe you don't have so 10-sided, but work is work. In this you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A all, and here 1 trapezium here, 1 trapezium here, 1 trapezium here, and 1 trapezium here. 4 trapezium in this. This angle is, you can say 144. This angle is 18 here. This angle is 36 here. 36, right? 44, I'm sorry. Yes. 36 here. This is 90, of course. This is 18. Because if we take 54 plus 36 is 90, is 144, this is 90, so this is 54. 54 plus 36 is 90, and this is 90, so it's 180, it's 18 here, 72 here, 72 and 18, 90, and this is 90, and here, symmetrical here, so this 36 here, 54 here, so this is where parameters are. So what we have to do, A we know, B we have to find here, B vertical dimension we have to know, B we have to find, that is, of course, A sine this value, 54. B is A cos 54, C is A sine 54. Similarly, D is A cos this angle 18, and F is, of course, F is, of course, A sine 18. Similarly, here we find H and I, and we can find G. Of course, H we can find from this angle A, whatever 36 here. So we can say this 54, we can use either of these two, and we can find I and H. So these trapezium 1, trapezium 2, trapezium 3, trapezium 4 are solvable like that. So we can say that. We now go to calculations, means what it says now. This is 10-sided here. Angle is 144, side A is known. B is A cos 54, C is A sin 54, right? B is A cos 54, C is A sin 54, D is A cos 18, is equal to E is equal to C, F is A sin 18, G is A cos 18, H is A cos 36, I is A sin 36. I repeat, you can say, let us see. B, actually we have to go to that one, means you can verify, that's not a big issue. base is cos. A cos, B, C is sine, when B and C, D is cos again, F is sine, then G is cos again. Like that, we can calculate all these angles. Calculation cos 54. We can say here it is sine, here it's cos 18, 54, 54, 54, 18, cos 18, and this is A sine 18, this is cos 18, and this is cos 36, and this is sine 36. So we got this. What we need is, now we need is calculations. This I said A, B, C, D, all cos. So angle you have to find, and then you can say what we are going to say. Now trapezium area 1, trapezium 1, 2, 3, 4. Yeah, all 4 here. Now trapezium 1 does say, let us say A plus C plus A plus C. A plus C plus A plus C over 2 into B. Here's B. Similarly, C plus A plus C plus F plus E, F plus C, F plus C plus A plus C plus F. This is F plus E, F plus E plus A plus E plus F divided by 2 into D. So these, again here we will take same F plus E, in this case F plus E plus A plus some trapezium I'm talking, sorry, this I'm talking, F plus E plus F plus E plus here A plus E plus F plus here H, yes, H plus A plus H over 2 into G, and here you can say H plus A plus H plus A over 2 into I. So these trapezium dimensions are here, and area calculation is there, so we can say 4. All these as repetitive E206. So this is E206 is this is B. B is here, that is E206. So it's okay. So similarly, we move over here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 dimensions, and we can verify if 0 is okay, fine. 0 to 6, similarly we can find this one by 1, 2, 3, 4, 5, 6, 7, 8. So here also same 1, 2, 3, 4, 5, 6, 7, 8, and then there's a 4 1, and we can get 206, 206, and 206, and 206, like that, A, B, C, D accordingly, where we get whatever B, D, and we get this sum of all these 4. And we got here 769, and by this formula also we get A square 2n, and this 769. So this means our 10 figure also works here. Well, I think you got understanding of polygon calculation using worksheet, or you can say, let me just put it there like this so that it will be clear. Hold on. Okay. All right, now we got to this is 10 sided, 11, 12, etc. we'll do later on, because let us now we are going to do better one, and that's a combination of these figures. Combination means just I'll show you diagram first. This is this is a triangle in direct. This is a triangle and circle. This is a triangle and circle, and then it is a right triangle in a square, and you can say it's a trapezium, and you can say in a trapezium having triangle within this, and here is isosceles triangle having a right angle within this and 4 right angle outside. Then this case your pentagon are fixed on square sides, which is resulting figure here, and also Here's a pentagon which is fixed on three corners of a triangle, isosceles triangle, and this is a cut of square, a cut of hexagon in octagon. This kind of geometry is very important from construction viewpoint or from various viewpoints. We are combined calculations here I'm calling. So this is that. Let us see how to work on that. It's of course very complicated, but once you have formula, means you have got this formula ready made, you have just to combine these two technically as well as calculation wise, and it's not very difficult if you concentrate on that. Only concentration on cells required, formula available. You have to combine this formula and understand how to proceed. Your variables should match, and if you think your variables are fine, you will get answer fine. You have to see how to combine area, planar area, how to combine planar perimeter, how to differentiate between two in terms of units, and how to convert them into vertical extrusion of 3D solid. To an extent volume is concerned, whether you have to subtract it from bigger to smaller one from bigger one, or you have to add these two, and how to handle surfaces, because in some cases surfaces shall be deducted, while in some cases volume shall be deducted. It depends on your requirement. It's not dictated by computer itself. You have to understand and accordingly apply, but formula is here for support, because variables of both formula, or even you want to make one more formula to be added, you can add 3 or 4 formula, depends on which geometry you have. So here I am going to demonstrate about combination of various shapes, and there's no limit, it will continue, but I'm just giving you few examples. That combination, for example, in this is triangle in circle. Triangle in circle, which is triangle in circle, in that case what we have to do, we have to combine triangle in the circle, means we have to subtract triangle, because inside is triangle in circle, so we have to subtract triangle from circle. That's what is here. And in this case we require two formula, one that relates to circle as well as other that relates to triangle. Both formula have to be put together, and we have to then, triangle dimension must be less than circle, because triangle is located within circle. If circle is located within triangle, then case will be reverse. So this I'm trying to explain to you a kind of practical method. Means, as I said, this is app 22, combine triangle in circle. Triangle is lying within circle. Subtract triangle from circle. This means we require circle formula as well as triangle dimension. So what I done, I pasted here triangle ordinary triangle, and this is open cell, and this is your triangle here. This is your triangle, same copied here, and we'll see dimensions adjustment later on. Now we understand how to do it. Now it's a circle, because we are using here triangle and circle both. So I also pasted here circle complete formula, and this is circle. Now what to do? These two formula are there. How can we use them? That's the point of procedure. Combine calculation, that's what is required. Combine calculation. There is no variable in calculation then except in this formula which we procured from previous records. We procured one triangle, ordinary triangle, and we procured one circle. We placed here with variables, that is yellow highlights, and we can change anything out on these cells. We cannot change formula results. We cannot change formula. We have no right to change them. If we change them, means we change our calculation, we destroy our formula. So therefore, once you do that, this can be logged in This can be, all these cells can be locked in. There is a way in Excel or in Lotus you can lock them. You can keep only those cells which are editable to be free, to be open, and other can be locked in. There's a procedure for that. We'll see later on, because in my file, that this old one, your file may be having that one. Your file means your Excel software may be having those arrangements. Keep these open. I mean, practically keeps the cells open and lock other cells, so that you cannot abuse those cells by error even. If suppose you cause an error during working, these formula results, which are non-highlighted white one, shall not be impacted upon by a wrong entry. Only these can be. If there is a wrong entry in this, you can change. There is no problem in that. Now what to do? Combined calculation, I am saying area circle, area triangle, subtract 2 from 1, circumference, perimeter triangle, some like this, all are given. This is very simple. Let us say what? I say area circle 1, this is here. I say E218, in this case, can be different in your case. Say this is area circle. Now, circle is here. I have area here. Area, this is area. So here in this case, it is here 218, E218. So I put here area circle 1. Area triangle is in triangle, and we can say area half base plus here. So this is area 214, and this is here 214, E214. Now, because triangle is inside circle, so we have subtract this area of triangle from circle. So you can say, see this cell minus this cell. So we got this, all right. We subtracted triangle area from circular area. Now circumference. Circumference, because there is no parameter in case of circle. So circumference of this is, which is circumference here, yes, it's here 2 pi r. This is here, so perimeter triangle, we have to find perimeter of triangle, and that is, perimeter of triangle, which is here somewhere. Area, open cell, this is pi, this is a coefficient 2 pi r. So 2 pi r, circumference of circle, and triangle I am talking here. Triangle, left hypothesis, right hypothesis, perimeter. This is perimeter. This is 12.85, and which is this one here. So you can link, I link this to this one. I positive put, this is linked to this one. What means? We have cell here, means just link that one. And that is 214 here, J214. So this is J214. And then we can say, let us sum 3 and 4. So this I named 1, and this I named 2. This I named 3, and this I named 4, just for purpose of reference. So I can say that here is subtraction of 2 from 1 for purpose of area, from area to form, means deduct area of triangle from area of circle to get net area, and this is circumference and perimeter. You can say I add 2, because even if you subtract, perimeter increases or circumference increases in meters. So this is sum 3 plus 4. So we augmented this quantity. Now we go to 3D, and that is vertical volume. Here it is a 3D, that is a cylinder, you can say, kind of a circle, because it goes up. And we cap this, here is vertical volume 8 cubic meter. I have said that this is 5 here. This is vertical height. It can be any whatever it is, but whatever it is, in case of here, and here is 8. We can manage, but for procedure I'm telling 3D vertical volume. Now cylinder volume, this is cylinder volume, circle volume, and triangle volume. We can manage that, this minus this, because it is internal. So we can get this answer, difference of 2, and then we can say surface square meter 3D, that is cylindrical surface plus triangular surface. So this is K218, already we had, plus N124. Here we have N124. So it is there. N124, that is for is for triangle, and for this here we have here this one. So k, here k to 180 in this case, and that's we add, we got this one. So this is combined. Now we combine right triangle in square. Right triangle in square. Let us see how it works. See, if you see diagram, this is a diagram figure. This is right triangle and this is square. Triangle is inside the square. We have to, same way, we have to import this formula from manually from our same sheet if it is in same sheet, and if you have macro or if you have range from other sheets, we can use that also. Whatever way you manage, you organize, you can make any number of references of this formula to other sheets, there's no problem. Or you can even copy all this, because these are not linked to other formulas. These are linked independently. These are independent formula applications. So we are saying combine right triangle in square. Right triangle in square. So we have here square, and we have right angle triangle. Both formula put here together. And we have to subtract right triangle from square. We require square formula plus right angle triangle. We require this. Square bigger than right triangle, because square is outside and right triangle is contained in that. This is common sense, nobody would tell you. Now what is square? We have already worked on square. We have here side and volume, height, vertical volume, height, and all results are available. Similarly, in right triangle, all results are available. What we have to do, same way, we do not change anything on this formula except variables. We have right to change these variables, whatever we say according to our requirement, but we have no right to change this formula. These details of formula can't be changed in combination. If you change them, you destroy your formula. So what I say, dimensions can be changed. Example, A can be changed, B can be changed, or whatever you think you can be changed, whereas other you cannot change. Combination here is, so we have right triangle details, we have square details, we combine them. Square area is, say, this is the area, is from here. Right angle triangle area, we can area 1 minus area 2, we can deduct, so we deducted here. Square perimeter is this, that is, E2 to 6, and we say E2 to 6 is here parameter. Right angle triangle parameter is here, G2 to 9, this is G2 to 9 here. So we can say, add up them, combined parameter is this plus this. Combined volume is here, square 3D, combined volume is, it is square volume, vertical is this one, that is I2 to 6, I2 to 6, this is square area, I2 to 6, so into H, I2 to 6 into H, so we have 3200 here. In this case also right angle triangle, 3D vertical volume is here, this is J2 to 9, J2 to 9 here, so we get volume of this. So combined 3D is volume 5 minus 6. Volume 5, this is, I assume 5, this name 5, this name 6. So volume 5 minus 6 cubic meter, that is this one. We deduct J231 here minus K231 here. We get this volume. Combined surface area, if you say here, surface area that we name 7, that is for square, and 8 for right triangle. We get K2 to 6 here, which is, here K2 6, this is here, and we get surface area, and then we get right triangle surface area, that is K2 to 9 here, and we can say combined surface area sum after, because area is increasing, we have area increase of square and area of triangle, the surface area is increasing, so we have added these two and we say these are combined. So easy it is, you see. Then we go to application, and 34, that is combined triangle in parallelogram. Combined triangle in parallelogram. Well, I think you like them if you feel that these are good for you, even not for work, but for just calculative work of brain, calculative capacity of brain. It doesn't matter, but it gives analytical power. These formula are actually very interesting if you want to drive them, because if you have little interest in geometry or in mathematics or in calculations, this is something that can augment power of your mind, your concept, your power of mind means that you become an analytical person, a geometrical person. If you need that, you can use that, doesn't matter. So what I say, now combine triangle and parallelogram. Parallelogram and triangle, let me show a figure first, because I particularly prepared these figures for explanation, because without figures, explanation sometimes is very difficult. So what I say, let us say, this is that here is a triangle, ordinary triangle beside A, B and C, and there is a triangle in parallelogram. This is parallelogram. So we need to, now what we need is, let us go back and see what we need it. So we require here formula of parallelogram, which is here, and formula of triangle ordinary or whatever you think you can bring in. Now we have complete parameters of parallelogram. There is nothing that it's that and it's that and this is that. Ordinary triangle, half base into height. That's this one, triangle ordinary. Actually, I think the sketch is erroneous because it's giving A, B, C. No, it's ordinary. So, well, it can be anything. It doesn't matter, I think. Okay, now, yellow cells are your friends. You can convert them to whatever value. You can change their values. Again, I say cannot touch. So, what we need, what we require, combine triangle and parallelogram. Subtract triangle from parallelogram because triangle is lying within, and dimensions of triangle should be smaller than parallelogram. And required parallelogram and triangle is higher, parallelogram bigger than triangle. So what to do? You keep them just side by side and everything is calculated. You have just to change values if you want to change values here. And triangle is already there. So what we do, combination is important now. Combined calculation, parallelogram area 1, triangle area 2, area 1 minus area 2. So we get area actual. Parallelogram parameter 3. Now we name this triangle parameter 4. Combined parameter is this. Combined volume, parallelogram volume is this, and triangular volume is this. Combined volume is this, and combined surface area means parallelogram surface area is this, and triangle surface area is this. Combined surface area is this. That is where it stands for. Got my point? What we do, we just take from here. Let us say parallelogram area. Parallelogram area, there's F237 in this case, and this is here F32, this area here, base into height. This is parallelogram area, and we get triangular area from E246. E246, this is here, this is triangular area. Both deduct, we got this, then parallelogram parameter. Parallelogram parameter, this is here. 237G, and we got 237G, and then triangular parameter this, and then combination of these two, 3 plus 4, and similarly we can take parallelogram volume, that is 241, it is 241I, and we can say I, no, it's a parallelogram, volume 5, this is I241. I241, this is yes, volume, and this is there, and then combine triangle volume 6, triangle volumes from volume 6 is M246, and that is here, M246. We got this, and we can say combine 3D volume, reduction of this 5 to 6, 6 from 5 give us, and similarly these areas to be added, and that's what is done. That is J240